NASA's Voyager 1 spacecraft has successfully crossed the boundary into interstellar space. After launching a spacecraft 45 years ago, it still explores regions once deemed unreachable, far beyond its expected operational life. This remarkable achievement of an evolved NASA mission is redefining the future of space exploration. However, what's even more astonishing is that this courageous spacecraft, though millions of miles from its starting point, continues to send back valuable data to Earth using technology that predates cassette players. But there's more. The spacecraft, launched in 1977, has just made a discovery that has sent shock waves through the scientific community and captivated global attention. What exactly is this incredible finding from the distant reaches of space? And how does it impact life on Earth? There was a pivotal moment in history when two of the most groundbreaking space missions were launched, marking the beginning of modern space exploration. It was through the brilliant mind of Gary Flandreau at NASA's Jet Propulsion Laboratory that a perfect trajectory was identified for a spacecraft to visit the far-flung planets, Jupiter, Saturn, Uranus, and Neptune. Using just a pencil and 21st-century engineering tools, Flandreau made an astonishing discovery. In the late 1970s and early 1980s, a rare cosmic event occurred. The four gas giants were aligned in a configuration forming a kind of celestial necklace along with Earth. This alignment meant that spacecraft passing by each planet could utilize its gravity to gain speed, as if being pulled by an invisible rope. Thanks to this gravitational support, what would have been a 30-year journey to Neptune was cut down to a mere 12 years. However, this alignment occurred only once every 176 years. Seizing this rare opportunity, NASA launched two identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart in the summer of 1977 to capitalize on this cosmic setup. Little did they know that these twin probes would shatter records and make history in space exploration. More than 45 years after their launches, Voyager 1 and Voyager 2 remain operational, transmitting valuable data daily from the furthest reaches of our solar system. These probes, now the most distant man-made objects, have traveled far beyond what was originally imagined, which is impressive, considering their mission was initially planned for only 4 years. However, these interstellar trailblazers were just beginning their journey, unveiling remarkable surprises. Early in their voyages, they provided stunning close-up photographs of Jupiter and Saturn's moons, revealing worlds far more dynamic and active than previously believed. The discovery of active volcanoes and ice fields on moons like Io and Enceladus completely altered our understanding of these remote parts of the solar system. Voyager 2, in particular, made history by becoming the first spacecraft to visit Uranus in 1986 and Neptune in 1989, remaining the only probe to ever venture between these two planets. It sent back groundbreaking findings from previously unexplored regions. Even at a distance of more than 14 billion kilometers from Earth, these robust probes, about the size of a Volkswagen Beetle, have defied all expectations and continue to push the limits of human knowledge. The Voyager missions began with an unprecedented gravity assist maneuver around Venus, a move no other spacecraft had ever attempted, setting them on a path to Mercury. The journey to Jupiter took the spacecraft 10 times the distance from Earth to Mercury, requiring them to pass through the perilous asteroid belt, a challenge already overcome by the Pioneer 10 and 11 probes. But the obstacles didn't end there. With only 69 kilobytes of memory, far less than a modern smartphone, the onboard computers had to rely on their own ingenuity to manage the complex demands of this exceptional mission. Data gathered by instruments on the Voyager spacecraft was stored on magnetic tape recorders before being sent back to Earth using a transmitter that consumed just 23 watts of power, about the same as a regular light bulb. The probes were outfitted with 12-foot diameter satellite dishes to facilitate communication, using light-speed radio signals to send and receive messages. Yet, as they drifted farther from Earth, communication faced major challenges. Signals from Voyager 2 now take over 18 hours to reach Earth, and increasing interference from radios, televisions, cell phones, and other electronic sources has made it harder to pick up these faint signals. Despite all these challenges, the Voyager probes have continued to exceed expectations, astonishing astronomers with unexpected discoveries in the vast emptiness of interstellar space. Their journey has transformed our understanding of the universe and shifted our perspective on the unknown. Beyond our solar system lies the mysterious Oort cloud, a vast collection of comet-like objects held together by the sun's gravity, stretching toward the nearest star. While the Voyager spacecraft are still moving slowly toward this distant region, their entry into interstellar space began when they crossed the heliopause, the boundary dividing the solar system from interstellar space. Initially, this boundary was believed to be around 50 astronomical units from Earth, leading to continued funding for the mission as it approached this milestone. However, when the spacecraft crossed into interstellar space, scientists were surprised to find no immediate change in the surrounding environment. It had been expected that this transition would bring an abrupt increase in cosmic rays, high-energy particles traveling near the speed of light, originating from supernovae and other cosmic phenomena. Yet, most of these high-energy particles are deflected by the heliosphere's magnetic shield, which protects our solar system from external cosmic threats. The Voyager mission team also closely monitored any shifts in the magnetic fields as the spacecraft ventured into interstellar space, an environment filled with ionized gases influenced by neighboring stars. Scientists expected that the interstellar magnetic field would be oriented differently than the heliospheric one. However, the probes didn't detect any significant changes in the magnetic field. It wasn't until August 25, 2012, that Voyager 1 finally passed through the heliopause and carried back fascinating data confirming an increase in plasma density, but without any evidence of a shift in the magnetic field. As scientists, this was unexpected. They had anticipated a noticeable change in the magnetic field's direction when transitioning from the solar-dominated region to one influenced by other stars. As Voyager 1 and Voyager 2 push further into interstellar space, their discoveries continue to challenge and expand our understanding of the cosmos, continue to reshape our understanding of the universe. What began as a mission designed to investigate planets further afield has turned into a journey that has opened the door to new uncharted territories. These spacecrafts have not only provided us with invaluable information about the planets they visited but also about the very boundaries of our solar system and the environment beyond. Despite their distance from Earth, both Voyager spacecrafts are still sending data that gives us insights into the space between. The interstellar medium, or the space between stars, has proven that space is not as empty as we once thought. Instead, it is filled with a variety of particles, gases, and magnetic fields that behave in complex and unpredictable ways. As Voyager 1 ventures deeper into this unknown space, it is anticipated to keep playing the role of a messenger from the farthest reaches of human research for many years to come. Even as technology has advanced, the sheer endurance of these spacecrafts is a testament to the foresight of the engineers and scientists who planned the Voyager missions. Their ability to continue sending data after more than 4 decades of travel is nothing short of extraordinary. In an age when technological obsolescence happens rapidly, the longevity of Voyager represents a remarkable accomplishment of planning, inventiveness, and resourcefulness. Voyager 1 and Voyager 2's discoveries have changed the way we view not only our solar system but the broader universe. These probes have given us a glimpse into the vastness of space, showing that there is much more to explore than we ever imagined. As they continue their journey, they will inevitably encounter more surprises and provide us with more data that could alter our understanding of space, time, and our place in the cosmos. These missions were born from a bold vision and the relentless pursuit of knowledge. When NASA first launched these spacecrafts, they had no idea just how far they would go or how long they would last. But through years of innovation, the Voyager spacecrafts have far exceeded expectations and continue to capture the imagination of scientists, astronomers, and people around the world. Their journey serves as a reminder of the curiosity and determination of humanity to explore the unknown. While we may not know exactly what the future holds for these remarkable spacecrafts, one thing is certain: they have already left an indelible mark on the history of space exploration. The discoveries made by Voyager 1 and Voyager 2 have not only enriched our understanding of the solar system and interstellar space but also demonstrated the incredible potential of human ingenuity. Their journeys also serve as a reminder that, even in the vast emptiness of space, there are still wonders to be discovered and that the quest for knowledge is never-ending. As Voyager 1 and Voyager 2 continue their solitary paths, we eagerly anticipate the new information they send back. Their legacy will inspire generations of future explorers and scientists to continue pushing the boundaries of what we know about the universe. As Voyager 1 and Voyager 2 continue their incredible journey through the vastness of interstellar space, they remain symbols of human ambition and the need to uncover the mysteries of the cosmos. These missions have not only transformed our understanding of our own solar system but have also provided humanity with its first close-up look at distant regions of the galaxy that were previously unreachable. The spacecraft's voyages have taken them to the furthest reaches of space, where they are uncovering new information that could change the way we perceive the universe. Even as the technology aboard these probes grows more outdated, their durability is a testament to the foresight of the engineers who designed them. With their limited memory and primitive technology by today's standards, Voyager 1 and Voyager 2 have continuously sent back groundbreaking discoveries, proving that even older technology can accomplish the unthinkable when paired with ingenuity and careful planning. Their persistence is all the more remarkable considering that the spacecrafts were only expected to operate for a few years. Yet, more than 4 decades later, they still function, delivering valuable scientific data daily. This incredible longevity serves as a testament to the ability and dedication of the scientists and engineers who built these spacecrafts. Their work has left a legacy that extends far beyond the original mission and continues to shape the field of space exploration. As these spacecrafts drift further from our solar system, they are providing us with unprecedented perspectives on the very nature of space itself. They have provided scientists with fresh information on the structure of interstellar space and the forces that govern the motion of stars and galaxies. The data that Voyager 1 and Voyager 2 are returning has already begun to reshape our understanding of the universe, suggesting that the cosmos is far more complex and dynamic than we ever realized. What's even more amazing is that, as these spacecrafts travel farther into uncharted space, they are becoming pioneers of an entirely new kind of exploration: the exploration of the void between stars. The space between stars was once thought to be empty, but the data from the Voyagers has shown that it is a far more active environment than anyone could have imagined. With each passing day, Voyager 1 and Voyager 2 send back more data about the space between stars, data that is leading to new theories and discoveries about the very nature of the universe. Looking ahead, these spacecrafts may eventually reach the boundary of the Oort cloud, a distant region of icy objects that extends far beyond the planets. While this area remains largely unexplored, the Voyager's journey through it will undoubtedly yield new findings that will help scientists understand the formation and evolution of our solar system, and perhaps even the origins of life itself. In the coming years, we can expect even more revelations from these incredible probes. Their interstellar exploration is still in its infancy, and as they travel farther from Earth, they will continue to provide valuable data on the conditions that exist far beyond the reach of our sun. Scientists are optimistic that the data from both Voyager 1 and 2 will provide insights into cosmic phenomena that are otherwise inaccessible to us. Despite all the challenges the probes face, including signal loss as a result of their vast distance from Earth, their transmissions remain one of the greatest achievements of modern science. These spacecrafts have made discoveries that have altered the course of our knowledge of space. What was once considered the edge of the solar system has turned out to be just the beginning of an incredible journey into the unknown. The data collected by the Voyagers is a precious resource for scientists, and will continue to guide future generations of explorers as they push the boundaries of human knowledge even further.